Hey, okay, here we go. Last math video of the high school career and year and everything. So, oh my gosh, let's start. So today we'll be working on the free response question from the Calc BC test 2013. We're going to be doing problem number 5. And here we've saved the best friend for last. Well, okay, I love all of my friends, but come on, this one is Thorar, like, he is above all. Anyway, he's making sure that you all know that you are worthy for this problem. So this bad mamma jamma right here is number 5, and for this problem you need to use Euler's method and L'Hopital's. It honestly is not that big of a beast of a problem. Like, we'll get through this, you'll be okay, and you will not have questions afterwards either, which is really good. Okay, let's go ahead and get started. We're going to easily break down this problem. Okay, so you're given that dy dx equals y squared times 2x plus 2. Then you're given y equals f of x, and then f of 0 equals negative 1. Yeah, that's right, Thorar. We can conquer this realm. So let's start with a fresh piece of paper. Part A. So it's asking you to find the limit as x approaches 0 of f of x plus 1 over sine of x. We find that if we directly plug in 0, we get 0 over 0, which does not give us a real answer. But wait, isn't there something you can do if you get 0 over 0? There is, and it's called L'Hopital's. So with L'Hopital's, you take the derivative of the top function, and then you'll take the derivative of the bottom function completely separate. And then if it gives you 0 over 0 or not a value, then you either do it again or it just doesn't exist. And if it gives you an actual value, then that'll be the limit. So with here, you'll get f of prime of x, and then over cosine of x. And so f prime of 0 is you'll take the 0 and then f of 0 and plug it into your given derivative equation. So that'll give you the top, and then cosine of 0 is obviously 1, so your limit will equal 2. Okay, so now we're done with part A, so let's move on. Okay, so part B. You are going to be asked to use Euler's method. Your starting point will be x equals 0. You will be using 2 steps, and you will be approximating f of 1/2. Just a refresher, our given derivative function is dy over dx equals y squared times 2x plus 2. You are going to be needing that along with the given value, which is f of 0 equals negative 1. So x is 0 and y is negative 1. First, you're going to need to find the slope of the line at this point, so you're going to plug in 0 and negative 1 into your derivative function. And by doing that, you'll get 2. Now you're going to create a point-slope form at that point. So y plus 1 equals 2 times x minus 0, which then you can solve for y, or you can directly plug into your x value that you're using, but I chose to solve for y first. And then here you're putting in 1/4 as your x. You're right, Thorar is asking the right question. So where did that 1/4 come from? Remember, when you're using Euler's method, you're always going to use equal steps and then whatever it gives you. So for here, you're using 2 equal steps. So since we are trying to approximate x equals 1/2, you just divide 1/2 by 2. And that's how you get your 1/4. Okay, so back to solving the problem. You plug in 1/4 for x, and when you solve, you get f of 1/4 equals negative 1/2. And then you repeat the same thing all over again, but with your new point, which is 1/4, comma, negative 1/2. And by solving, you get y equals negative 11 over 32, and that's your point. Okay, let's move on to the last section of the problem. Part C! Okay, so we are finding y equals f of x using the given point. So now we get to solve for y, which is going to be great because now you're making that derivative and we're going to split that apart and it's going to be great. So since it's multiplication, you can split them. So it's going to be dy over y squared and then the 2x plus 2 dx. Then you're going to take the integral of both. If you want to split up the x side, you can. I did just because it's easier to spread everything out and look at everything a lot clearer. So once you take the derivative, you have to add c at the end, and so now we get to solve for c. Please ignore the big scratched out box. Anyway, so to find c, you'll plug in the given point again, and you'll get c equals 1. But we're not finished because now we have to solve for y. So you can actually make the y and the x just sort of switch places, which if you want to get technical, you divide the x part and you multiply the y part by both sides. So it's going to look a little something like this. Since that was your answer, now it's time to grade. So for part A, it calls for you get a point if you do the little hoppy tiles, which we did, right there. And then it also calls for a point if you get the answer, which we did, right there. It's number 2. So for there, we get both of the. So for part B, we get 1 point if we did the Euler's method, which we did, right there, next to the +1 with the circle around it, because that's our 1 point. Also for part B, you get a point if we got the answer, which we did, right there, next to the +1 with the circle. It's the -11/32. Woo! See, even Thoreau's happy. We got both points. Alright, part C, we get 1 point if we separated the variables, which we did, next to the .1 in the circle. The next point, which is for getting the antiderivatives, which we did in the corner, and there's a little +1 in a circle right next to it, so we got that point. The next one is for finding C, which is equals 1, and there's a +1 next to it, so we got that one as well. To get the next point, you have to use the initial condition, which you did. Whoop. And then the last point is for solving Y. So since we did that, we got all 5 points, and since we got all of the points and all the other ones, we got the total of 9 points. So if you want more practice problems just like these, there's 2005 number 4, 2010 number 5, and 1999 number 6, and those should get you the practice you need. Well, that's weird. Who's that? I have no idea. What? Well, it looks like Thoreau had to go save the world. But he called in his little friend, who's kind of creepy looking, but you know, it's okay. Well, he is wishing us good luck. And good luck to you. Thank you for watching, and this concludes any calc video I will probably ever make because senior year. Alright, bye!